we are going to start zero of a polynomial. So here we will study how we can find the zero of a polynomial. So I'll go step by step. First we will go learn for linear polynomial, then we'll go for quadratic, cubic and polynomial in two variables. So let's start. First is linear polynomial. We know linear polynomial means degree, highest power or degree is 1, and we are studying for one variable. So here I have taken an example 5x plus 10. You know very well it's a linear polynomial. Here because here degree of x is 1 and it is of one variable, because here is only one variable, that is x. So formula is to find the zero of a polynomial. There is a shortcut, there is a formula, that is minus constant term upon coefficient of x. Here the numerical value which is alone without any variable, that is a constant term, and the value which is before x, the numerical value which is before x, that is coefficient of x. So let's put this value in our formula. Minus, because there is a sign in minus in formula, so we need to put minus sign here. Then constant term is plus 10, so 10 will come in the bracket. Here it is in plus 10, so no need to write plus inside, it is obvious. Upon in the denominator coefficient of x. So what is the coefficient of x here? That is 5. So put coefficient of x in denominator. We know minus plus will become minus 10. So minus 10 upon 5. When we will cancel out, it will become minus 2. So here we found the value of x is minus 2. It means if we replace x by minus 2 in the linear polynomial, we will get 0. Let's see. Let's cross verify it. Our linear polynomial is 5x plus 10. Let us replace this x by minus 2. Let's see. 5. There is no sign between 5 and x. It is obviously that is multiplication. 5 into minus 2 plus 10. Let's see. 5 into minus 2, we know minus 10. Minus 10 plus 10. That will cancel out. It will become 0. Therefore, we can say minus 2 is the zero of the polynomial. Let us take one more example where I have taken the minus sign in between. So here the formula is minus constant again upon coefficient of x. Here constant term is 8 or minus 8. Here constant term is minus 8 because there is a minus sign between constant term. In that previous example there it was plus 10 and we no need to write plus, but whenever a minus comes in between, we need to write minus with that constant term. So formula is minus will remain same, then in bracket minus constant term. So constant term will come with their sign minus 8. Here coefficient, again the numerical part with x, that is the coefficient of x, that is 4. So let's see, minus whenever two same sign multiply, it will convert into addition. So it will convert in plus 8 upon 4. Again it will cancel out, it will come 2. So let us replace again x by 2 and let's see whether 0 comes or not. Let's see, our equation is 4x minus 8. Let us replace this x by 2. Here I have done 4 in bracket 2 minus 8. 4 to the 8, 8 minus 8, answer is 0. Therefore again 2 is the 0 of this polynomial. So we can say that from this formula we can easily find out our 0 of the polynomial, or we can say by what number we should replace our x so that we get 0. Now come to the general form of this linear polynomial. Here example is 5x plus 10. General form of linear polynomial is ax plus b. So what is a and what is b? See here in the example 5x plus 10. Here the numerical part before x, that is a, x will remain same, and the constant part, that is b. Instead of writing this whole formula minus constant upon coefficient of x, you could write minus b by a. B is the constant part and a is the coefficient part. So there is one more thing that you should note down. that in this general form or in this linear polynomial, a constant part can be 0, means a constant part can be missing, but the numeric, but this ax part, the part which is with coefficient of x, can never be 0. Let's see one more example of linear polynomial, that is 4x. Here you can see it is ax, means coefficient part is there, but the constant part, like here the constant part is 10, here the constant part is missing. Again see one more example, 5x. If in this example I'll cancel out, I'll rub this 10, then it will become 5x. So again it is a linear polynomial because its degree is 1, and here numerical or constant part is 0. So can we find out the 0 of this polynomial? Yes, again with the same formula. Minus constant is 0 upon coefficient of x. Here coefficient of x is 4. So minus 0 upon 4. Whenever a number 0 divides by any number, it always comes 0. Therefore here if we replace x by 0, we will get 0. Got it? I hope this linear polynomial is clear. So let us come to the second, that is quadratic polynomial. Now what is a quadratic polynomial? You all know very well, a quadratic means which has degree 2. So let's see quadratic polynomial. First of all, degree is 2. Let us see the general form of quadratic polynomial. General form is ax square. I have told you whenever a degree is 2, the maximum term it can have 3. Ax square plus bx plus c. Again c is the constant, b is the coefficient of x, a is the coefficient of x square. Here you need to note down that here ax square means a part, here you can say a can never be 0. Like in our linear polynomial ax plus b, a never be 0. Similarly here a cannot be 0. So let us take one example of quadratic polynomial, that is x square minus 2x. You can see here constant part is 0, but x square is there. Let's take one more example, x square plus 5x plus 6. Again both are the quadratic polynomial because highest degree is 2. So I'll tell you that there is no shortcut, there is no formula to find out the 0 of this polynomial. There is only one method, that is splitting middle term, or there is one more formula that you will learn in the later classes, splitting the middle term. Let's split this middle term. I am not telling you how to split, I am doing directly. After splitting you will get x plus 2 and x plus 3, two factors. From here you need to calculate the value of x. When you will put this x plus 2 equals to 0, you will get the value of x, that is minus 2. Similarly here you will calculate this equate to the 0, you will get value of x, that is minus 3. That means if you put this x in this equation, value of this x minus 2 in this equation, you will get 0. Similarly here let us do this question, x square minus 2x. Let put x is equals to 0. Let's try 0 square minus 2 into 0. What will you get? 0. Let's see, put x is equals to 2. Let's put 2 square minus 2 into 2. 4 minus 4. Answer is 0. So from here we can conclude that a quadratic polynomial can have maximum 2 zeros. Therefore we can say that there exist only two values of x, by which if we replace the x we will get answer 0. So what will happen in the case of cubic polynomial? Let's see. Cubic is also a, what is a cubic polynomial? Cubic means degree 3. Therefore, from our last two examples, we can conclude that in cubic polynomial, number of zeros will be 3. Or finally, we can say that number of zero cannot exceed degree of polynomial. In linear, there were 1 0. In quadratic, there were 2 zeros. In cubic, there will be 3 0. You can try by taking any example of a cubic polynomial. And there is one more thing. If you will draw the graph, you have studied already chapter number 4 and chapter 3. If you do the graph of linear polynomial, it will be like a straight line that will pass the x-axis at one point, or wherever it will touch the x-axis, that will be the 0. Similarly, in quadratic polynomial, it will cut the x-axis by 2 times, and wherever it will cut the x-axis, that will be the 0. Similarly, in cubic polynomial, it will cut the x-axis at 3 times. If you want to see, you can draw and take the look at the graphs, then you will get. Okay, thanks.